Thank you, Jeremy. Looks like we are live.
Yeah, I believe so. So let's see. I'm going to hand host over to somebody. Should I hand that over to Sarah or Ian? Who wants to kind of
I
help
think
me
Sarah.
host? Sarah, okay.
Great.
Sarah, I'm going to make you host.
Okay.
And I will leave you folks to it. Nice to see you all. I've got to drop out, but have a great session.
Thanks, Jeremy.
Thank you. How is everyone?
Good.
Good.
Here at the university, we're just overwhelmed with the end of the semester fast approaching. So I know all of our students are going to be really happy in another couple weeks.
Yeah, it's a really busy time.
Hi, Maria.
Hi.
So this week, this is a combination between the new member meetup and the education meetup.
Mhm.
And we thought we could talk a little bit from both perspectives. Similar challenges, I think, getting these programs going and sustained at universities as starting new chapters in any context.
Okay, sounds good.
And we also usually have some K through 12 people talking as well. I expect Rick will be here too from the new member meetup side. I'm joined here with Nush, also from Brandeis, who's working on an exciting project that I'm sure we'll talk about in a little bit too.
Awesome.
And Maria, where are you joining us from?
I'm based in New York, but I'm Ukrainian. So I'm kind of in between two worlds. Yeah.
I imagine.
Where are you?
We're just outside of Boston.
Oh, nice.
And we do have a small local chapter at our university that's made about 15 hands over the last 5 or 6 years.
Mm-hmm.
But now, thanks to Nush, we're getting more into the information systems design side of e-NABLE. We realized we can make a few hands per year, and I think that's very impactful for the recipients and for the students. But even more, we can design better information systems for how do you find the right design and how do you match one of the hundreds of designs for the right type of limb difference.
Mm-hmm.
Really a hugely complicated problem that Nush has undertaken as an intern this semester.
That's amazing. Yeah, I'm a master's student in design and technology. So I'm trying to write my thesis about this in relation to Ukraine. And I guess this is a part of my research, but also just like a desire to do something. So it's nice to be here.
There's so many different angles, I think, beyond just making the physical devices.
Yeah.
There's lots of opportunities for contribution.
Definitely. And just thinking about how to even start this conversation in places that are impacted and not necessarily come from the same day-to-day world,
Absolutely.
So
we've noticed too that there's different regions have different strengths and weaknesses.
Mm-hmm.
And one thing, US education has a lot of enthusiasm for building the physical prototypes, but we don't have as much connection to recipients. And there are other places like Brazil where this has been integrated into the national healthcare system, and it's much more accepted, and there are many more recipients, but there's less groups producing designs.
Yeah, a lot to learn. Would love to get some resources from you.
And I think Nush has done a ton of research reaching out and interviewing different folks in the community. We've sort of realized there's an information overload when you have to get started somewhere.
Yeah, that's for sure.
And we also all sort of view the design landscape of e-NABLE differently in our own brains. And there's so many different ways to approach, how do we even select a prototype and match it with the use case?
Yeah.
Hi, Chris. So I think Rick will be here shortly from the new member side. And I'll wait a little bit and we'll have Nush talk about some of his research on information designs. But maybe we could start just by doing quick introductions. So I know we're also joined by Sarah, who is organizing all of us in the e-NABLE community. Sarah, do you want to introduce yourself?
Hi, I'm Sarah. I'm usually in Minnesota, but this week I'm joining you from Rochester, New York. And I am a communications coordinator slash fellow in the e-NABLE space, and I'm relatively new here. I'm also a journalist, and I have a background in public health and medical research and healthcare journalism. So I'm really happy to be here with all of you.
So exciting. And Sarah also helps organize all of the back end of all of these meetings and the hub and how a lot of us communicate. So thank you. That's been helpful organizing us. I see Rick is just joining up as well.
I am so sorry. I have not been able to get Zoom to come up.
Oh, no worries.
I was unable to launch Zoom and I don't know what's wrong. I don't have an explanation. This thing's crazy.
Well, we're always excited to hear from the crazy sci-fi stuff that you're doing.
Whoops. Yeah, we've got some new stuff we're still wanting to show you later on.
Cool.
It's been a designer's paradise over here. We've got something that we're pretty excited about, and maybe we'll get a chance to show you.
Oh, I can't wait. I thought we could do a quick around the room. I'll introduce myself. My name is Ian Roy. I'm the Director for Research, Technology, and Innovation at Brandeis University, where my team runs a lot of the public maker spaces. So we helped the first student group on our campus make a bunch of hands. And now we've gotten more into the how do we design better information systems question. There's been a couple interns from our university who've worked for e-NABLE, and there's lots of opportunities for other interns from other places in education to contribute. We've been looking particularly at redesigning the onboarding experience, which is great to be here with the new member meetup. I think it's always a pain point. How do you get started in e-NABLE? There's just so many resources to navigate. And then Nush has joined us as an intern this semester to redesign sort of the metadata around how we sort different types of hands. And one of our concepts is we sort of need a mouth of the funnel. How do people find e-NABLE? How do we find the right upper limb prosthesis design? And then how do we match that to a specific use case or a specific limb difference? So Nush, do you want to talk a little bit about your process and what you're trying to achieve?
Yes. Sorry, let me just, I can try to share my screen a little bit. Can everybody hear me?
Yes.
All right, once again, I'm Nush. Like Ian said, last semester of, in the final semester of the MBA program. And I've been working to try to kind of like three things. One, kind of like standardize the metadata schema process. The second one, to kind of like redesign the process flow. Let me just show it to you. Sorry. Okay. Sorry. Right here. Okay, great. Okay, so one is like the family tree, as you were talking about, in terms of like the branching out, and all these three steps kind of like flow into each other. And the third one, in a sense, like is the organizational part, and that is organization in terms of making it much easier for folks to get signed up and get like the resources or get what they're looking for, whether they want to learn how to reconstruct the hand, or they're looking for the hand, or they want to be a part of the community or so forth like that. I guess my goal in the sense is to kind of like streamline that process and make it very easier in the sense. Like one of the things that I've noticed over the last few months is that we have a lot of information, like sometimes way too much information especially for someone very new that are trying to enter the community and trying to enter the space. And sometimes sorting through those information and trying to find the right information that you need can sometimes be a little bit, especially if you don't have the technical background, in a sense like that, can be a little bit overwhelming and so forth. So my goal in a sense is to kind of like, as you're saying, the information wise, to kind of like streamline the process and to make it a little bit easier in a sense.
I'm so excited for the outcome of this project.
Mm.
And when we started, we were just looking at sort of all the e-NABLE resources, and we reached out to some other groups. And we
Yeah.
think a good place to sort of aggregate a lot of this information could be on the NIH's 3D Print Exchange, which
Yeah.
if anyone was involved in makerspaces around the pandemic, they were sort of a clearinghouse for DIY PPE, like masks and face shields that we could 3D print.
Yeah.
And reviewing that is a good place to organize a lot of the e-NABLE resources. So not reinventing the wheel, but just aggregating links and sort of sorting all of that information.
Definitely. Okay, I'm gonna stop sharing.
Thank you, Nush. Great to
Right.
see. And I thought we could also go around the room, just check in with who's here. Joshua, if you wanted to introduce yourself.
Hi, everyone. My name is Josh Taffel. I'm a teacher at Upper Darby High School. We are a large urban high school outside of Philadelphia. And we are interested in starting a chapter, getting something going here at our school with a group of students that are interested in going into the medical profession. We also like to try to, help people as well. So this seemed like an interesting opportunity.
Very cool. And yeah, we'd love to talk more and share tactics.
Good.
I think some of the groups pushing this the furthest are high school groups. If anyone has seen Sage Prosthetics, I'll put a link in the chat. We've been super inspired by what they do, particularly because they have a longer relationship with their recipients. They're not just making one hand, they're making a first one, getting feedback, refining it, which we see less groups doing globally. It's really a cool method. And Maria, we had talked for a moment, but give you an opportunity to introduce yourself.
Yes, hello. I am Maria. I'm based in New York and I am currently at NYU Tandon doing my master's program in integrated design. So I'm doing my thesis on 3D printed medical devices, specifically trying to focus on upper limb prosthetics or accessories. I am a part of a few volunteer organizations that are targeting help and aid for Ukraine. I'm Ukrainian, so I'm trying to glue these two interests or, things that I'm busy with right now together and find a way to help my city and my country.
So important. And thank you so much for joining us today.
Yeah, thanks.
And Chris, how are you doing?
Hi, feeling like a bit of a fish out of water. I'm based in London in the UK. And I'm a new joiner, so it said new members in the rubric for this. I've nearly completed my first hand. I've got a long background as a maker, 15 years of engineering and manufacturing. I've been working as a hospital administrator of different kinds for the last 15 years or so, I suppose. About to finish up with that, and we'll probably reach out to some of my pediatric therapies colleagues to see if they can create contacts for that, and also obviously to the UK chapters such as they are, and see what the state of play is and how to get in touch with people who need this kind of thing. It strikes me, looking at the chatter in the forum and actually just the figures on the front page of the e-NABLE website, that there's more people making than there are people wearing things. And so that's the easy part.
Absolutely. Finding the customers and really meeting their needs is definitely the highest challenge.
And understanding what's out there, I suppose, what the range of needs is in terms of different abilities.
It's such a good point. And there's so many different ways to contribute. I think, like, obviously the highest goal is making great hands for people that need hands. but there's a lot of material testing and design organization, and then matching use cases. I think, like Maria mentioned, the accessories is a really interesting point.
Well, yeah, it's the start of the journey. Hopefully there's a few more years in it for me yet.
Glad to have you on board.
Okay.
And Rick, wanted to give you an opportunity as well.
Hello, everyone. I have no idea if I've got my video working or not yet.
Not yet.
Not yet. Okay. I apparently broke it trying to get on. I'm Rick Williams. I am a builder, and I do quite a bit of design and things of that nature. And hopefully we'll all be working together soon.
I know Rick has really pushed the envelope with a lot of design and material integration and figuring out like some crazy sci-fi ways to approach the edge of what's possible with 3D printing and design and the e-NABLE platforms. And I do hope that Rick's video comes on so we can see what he's working on.
Yeah, I'm sorry about that, everyone. I have no idea what happened. It's too bad. I have something I really wanted to show you, Ian.
Could you join on a phone or something?
I think I could. Let me try that.
Cool.
I'll let you guys continue while I see what I can do here.
So I think the thing that sort of my background with e-NABLE has the strongest part in is on the fabrication side. More than the CAD side, the CAM side. Like, how do we set up a machine, variety of machines? How do we optimize and make that really good? And then navigating materials around that. So the material settings and the machine diversity has just exploded with what's possible today. And we've done a lot of R&D for the last 5 or 6 years in our lab around consumer grade printers and how we can push them to their limits. I know Nush built his first hand this semester, which was exciting. Nush, you want to talk a little bit about the challenges with that process? How'd that go for you?
Yeah, so I mean, obviously it's not the best of hands because it was my first design. Sorry, not design, my first build. So I mean, it's more than anybody, it's I guess one of the hardest part, and I feel the first try was after putting like the part that go around the arm itself into the water and hoping that it
the thermoforming is tough.
Thermoforming, yes. It was very difficult in a sense because it's like you calculating I guess how hard you can kind of like bend it and how soft the plastic in a sense would be, and how kind of like how neatly it's going to fit around the hands or so forth like that. So I found that to be very tricky. But the videos were the step-by-step video in terms of how you put the pieces together. I found that to be very educational, very interesting. Thank you, Chris. Very, very interesting, and it was very straightforward, and it helped a lot in a sense. But yeah, you can see it. This is my little hands. Still a work in progress, but yeah. And just the resources too that was available, were really good, like to help with the joints, snapping place, and all those things. I'm still learning, as you can tell, because I don't know most of the parts and so forth like that. But it was a great learning opportunity.
There's also an opportunity for us to discover, like, what are the best models to start with? Like, where do we start? And usually before we make one for someone, we just make one to learn the platform. Like, what platform do we choose for that? For me today, it's sort of all is driven by the 3D Universe kits. Those handful of kits available to get all the screws and rubber bands and all the parts that aren't fabricatable in a makerspace. I remember when I made my first hand, it was the Cyborg Beast, and there weren't kits, and I had to like find different screws where I could. I ended up using blind cords from a window blind like in my apartment that I like cut out of the window for the material. And having the kits available has really helped us get a lot more students able to build them. But are those the right kits, I think, is a big question for us. And most of those start from a wrist-based design.
I
Go
know
ahead,
that
Chris.
Jeremy's pushing very hard to build a bionics kit that can be purchased, that has all the parts in it, and we've been having that discussion. I guess it'll be a matter of what everybody decides on is the best build kit, easiest enough where somebody that, you know, maybe doesn't have soldering skills or something of that nature can still participate with.
And with bionics, it's for new members, the barrier isn't that high. We just mean adding like motors to it, essentially not making just a mechanical device, but something that can actuate itself in some way.
Animatronic.
Yeah. Did I finally get the video to work?
Yeah, we can see you.
Awesome. Thank you, guys. Sorry.
I found the forum pointed me to the Phoenix version freehand, which downloaded the parts, sized it to the recommended 130%, did that in the slicer. So I'm using a Prusa printer and slicer, and it just went without a problem, printed out nicely, fitted together. The puzzling bit is sourcing all the extra bits, because I didn't fancy paying postage to get all the bands and Velcro shipped from the States. So kind of taking potluck with eBay and Amazon for that. And I had no idea that there was such thing as dental rubber bands. I mean, what are those? And have I got the right ones? Are they too strong? Are they too weak? Yeah, so it's that side of it is a bit of a guessing game.
Definitely. And the global supply chain is a great point, that what we can get region to region is very different for materials. Welcome, Dave. Thanks for joining. Dave, if you want to introduce yourself, go ahead.
Yeah, so this is the first time I've joined a meeting like this on Zoom for the e-NABLE team, so it's a pleasure to be here today and a privilege. I'm a mechanical engineer with, I run a small business, and my business tailors to developing innovative technologies for special needs individuals. So I ran across the e-NABLE website as I was doing other research, and I said, wow, this is kind of cool. So I'm not on the perimeter, you know, I'm not like just looking. I want to get more involved, but I'm not yet really gaining enough traction to do that. So I'm listening today, but you know, I have a little extra bandwidth to get involved and help, and I'm just kind of checking things out. So thank you.
Great to have you here. I figure, Rick, since we can see you, is there anything you'd like to show us today?
Sure. I always have toys. One of the things that I think you're going to like, Ian, is this. And you're probably thinking, okay, that was fun. What does it do? It's actually a transmission. It's like a differential transmission. But what's interesting.
Oh, we lost your audio, Rick. Oh, we lost your audio. Rick, we've lost audio from you.
You're muted, Rick.
Send him a message. Oh, this is so cool. I wish we could hear. I know we've printed one of those public models of a drive differential to show how it works at larger scale. It looks like he's got a functional one there. But you can see the mechanism. We still can't hear you, Rick.
It would be extremely difficult.
Now we can hear you again.
Oh, sorry.
We lost you for a sec.
So basically, this little guy here is a super opportunity. I'm going to start cutting away some of the body, but it's a super opportunity to have an actual transmission that is not only inexpensive, but it would work much better than a standard Whipple tree, because as a transmission and also a differential, the two drive sides of the device actually can work independently, like a Whipple tree, where one can continue while the other one stalls. And we also found these are kind of neat. Let's see if I can get it up here. These are some new motors that we're testing. And these we're going to be using in the new bionic fingers. And what's really cool about these is they're 3.5 volts, but they have a built-in transmission. And so right now what we're struggling with is the RPMs. We're not entirely sure what the best mix is for RPMs, because we want to keep the spindle size small, because you don't have a lot of space in the hand. And one of the things we're focusing on, I didn't personally realize that there was a study that had been done that 92% of amputees, upper limb amputees, are partial hand. I did not know that. And it's something that we don't really do enough of, I think. So we're focusing a little more now on some new projects that are partial hand related. And we're going to be probably using our vacuum forming machine to do that, because it's super cheap, super fast. And the vacuum forming machine that we are currently using, you guys, if you could either build it or you can buy it for $70 on eBay.
Wow.
It's an amazing bargain. And we're messing with a lot of different materials. I just heard Nush talk about materials, and he's absolutely hit it on the head. Materials are a huge issue, especially if you're dealing with heat, things of that nature, which is one of the reasons I really like the vacuum forming. We're going to be trying some Krydex. It's super strong. We were building animal prosthetics with it. Had great luck with the material. And I think that's what we're going to focus on with the partial hands.
Very cool. So then you can
We're
adapt
using
to
right
whatever
now,
physiology is there.
Well, what we're doing right now, Ian, is we're doing LiDAR scans of the hand, of the residual hand. And the LiDAR, then we convert it, we print that, and then we're going to put it on the vacuum forming machine, which will make an absolutely perfect replication of it with no 3D printing.
Very cool. Very cool process. Yeah. I think the
and cheap.
Go ahead, Dave.
What was
sorry,
the
Chris.
material you're vacuum forming again?
I'm sorry, Dave. Could you repeat? I didn't hear you.
I was curious as to what the material was that you're vacuum forming.
What we had been using was Krydex. I don't know if I'm pronouncing it correctly. What we had found out is they use it for extremely strong builds, like I guess gun holsters. They use it for different really super strong type vacuum forming techniques. And we're using 1/8 inch right now because it's so incredibly strong. You don't have to go much thicker than that. It's really, really cheap. I think we were talking like a 12 by 12 sheet is like $1.50, something like that, if you buy in specific sorts of bulk. And what's really nice is if you 3D print the hand and you're interested in, say, making a battery pack, rather than designing it in CAD, you could actually just glue gun the battery pack to the hand, and then when you vacuum form it, everything's just right there. So it eliminates an awful lot of the design issues that you would have to go through with CAD. I mean, it's not like we're afraid to do the CAD. We just, you're talking in some cases a day to print, whereas thermal with the vacuum forming, you're talking 8-9 seconds.
So let's see if I've got this straight. You fit the battery pack onto the hand, and then you just draw the Cridex over the two together.
Han, I hate to do this to you again. Could you give me that okay hand? What we will typically do is, I think that I heard you right. I'm just going to show you this hand because we cut the fingers off it sometimes to use it. I don't know why I have that silly background on here. I don't seem to be able to get rid of it. But what this is this is one as a for instance that was LiDAR scanned, and then when we go to print it, we'll just cut the fingers off before print. We'll hack them off with CAD, or we'll just print them a dummy, and then we cut the fingers off as needed for testing, and then we glue them back on for different configurations. So this is sort of our dummy. This is actually my hand, even has my fingerprints. And what's nice about it is we can then make these really, really nice sockets. And the socket is everything. It really doesn't matter how well you build the rest of the hand if the socket doesn't fit. If it hurts, they're not going to wear it. You know, so we stretch it a little bigger when we go to vacuum form it, and then we put silicone inside of that. And we have these new metal fingers now that we're attaching that have a 2,400 pound residual strength on the actual finger, not the tendon, but the finger. So we're going to be putting those on the new sockets, and we're going to see where it goes.
Thank you.
Now, if
really
you want,
exciting.
we can tell you more about the vacuum forming machine, but you can get them on eBay pre-built, and then you just supply a shop vac.
Really exciting too, what you've been able to do with these new accessible 3D scanners coming out on mobile devices.
Oh yeah, the LiDAR is awesome. And I think what's really nice is you start dealing with children and they're already comfortable with phones. So it isn't scary to them like a big old mean scanner, you know. Some of our big scanners are frightening. So to get a kid to settle down with a phone is just second nature. They're used to sitting there and playing with them. So scanning residual limb, they're not in the least bit afraid of a phone. And the LiDAR gets it down to almost perfect. We have some big industrials. However, they're terrible to set up. They're heavy. They're a pain. You know, you have to bring a Windows PC along. So what you're dragging around with you, especially for pets and kids, pets are hard too. How do you get a dog to sit still? But the LiDAR just does a great job.
And so for the new members, traditionally, like with a Phoenix V3, we would take several measurements around the hand and then use parametric CAD to make that shape based on typing numbers into software to generate a pattern. And this future of using the accessible LiDAR sensors on phones to get the shape data for whatever limb difference we're attaching to, this is a really exciting way to get a better fit that's way more custom to the physiology.
Oh, you're so right, Ian. And we have posted, I'm having trouble getting the request to send you a link. We have posted all of this on the hub. We actually show the actual device that we have, the thermoform, or I'm sorry, it's basically a box with some piping in it that's PVC and pegboard on the top. And it does a great job. I think we had $70 in it.
Wow.
That's it. I mean, $70. And we have saved a ton of money just on filament, time, energy, all the above. I mean, you know, I don't need to tell you guys, we had one that we were printing for almost 6 days and the guy came and pulled our meter off. And you're done at that point. So sometimes being able to vacuum form in a couple of seconds is awesome. And the Cridex looks an awful lot like it's just an amazing looking stuff. It looks like, what is that material that they use for the Nano. It's just super looking stuff, and it's so strong. You can't hurt it. It's unbelievable. So it was kind of a no-brainer for as cheap as the material is.
No, this is a great point. As we get more accessible 3D printers and 3D scanners everywhere, then we can move to much more interesting conversations about the material that's possible. And I like how you're using a combination of several different technologies to get there, using an additive process and a formative process and some hand finishing in between.
Yeah, it's interesting to me what they're doing with, I don't know if I should say this, but it's interesting to me what they're doing with the braces in the Ukraine, because this would be so much faster. And it's, quite frankly, if any of you have ever had to get a brace in the hospital, they don't use a vacuum forming machine, but they use thermoforming with a solid piece of material. And it's instantaneous. You can mold it almost immediately. You don't really even have to 3D print it. You just cut it. And when I had my amputation, it was just like that. They just heat it up, they put it on, and it stays. So it's a tried and true methodology. I guess I'm sometimes confused as to why we 3D print some of the things we do, but it's fine. It's just that the 12 by 12s are easy to ship, stronger. I don't know that we could 3D print anything as strong as the Crydex.
Definitely. And I think that the number one thing that I'm hearing from you, there's several interfaces we have to design on an upper limb prosthesis. And particularly for socket design, this is a killer way to get the interface from the device to the human to be more precise, more comfortable, probably
Yes.
easier to use.
Yes, and time-wise, depending upon the speed, I know you all have different printers, but depending upon the speed of your printer, it's not really that uncommon for us to print 3 or 4 days for some parts, and something can easily go wrong. And when we're doing
part we
the
were working
vacuum
on.
forming, yeah. And how long was that?
This was
That
like
had to be at least a
28
day.
hours or something.
Yeah. And the beauty of what you've done there is, first off, it's very cool because you've changed the coloring, which is really nice, in the layers. But imagine just being able to flash something of that nature in 10-15 seconds.
Oh, yeah, unbelievable.
Yeah.
It makes me think a lot about a TED Talk that I found very inspirational by Hugh Herr. I'm going to put it into the chat here because people might be interested, especially new members. And this is a professor at MIT who does lower limb prostheses. But the thing that got me there was talking about the different interfaces that have to be designed and how we can approach each of them with different technology.
Yes. Yeah, I'm in total agreement. I think there's room for all of them. They all have their place. But not everybody's, is a CAD guru. And sometimes, we all have to get the soldering gun out, to do some cuts and off times in our designs, rather than reprint it from scratch, because it is a long process. There's an awful lot of ways to skin the kitty, I think. And I think you have to be open to saying, well, like in our case, we're doing a lot of the base designs with CAD or with 3D scans, and then recreating that device to make a positive, and then the negative stretch over the positive with thermoforming or with vacuum forming. And it's an awesome combination.
I was wondering, Josh, what type of machines that you're working with? Oh, and welcome, Douglas.
Hello, everybody.
I think we all have very different material possibilities because of the machines that we have access to. And that's one of the complexities of this global effort, is we all have different technology capabilities.
I have a one quick question. I have both resin and FDM printers. Is one preferred over the other?
That's a great question. And I think a lot of it depends on the material going into the machines. I know resin has exploded in possibilities in the last couple of years. We can now do like flexible resins and high performance resins. And at the same time, we can do all sorts of different things with our stuff. Even within PLA on an FDM machine, there's varying additives in the PLA now that makes the failure states different. We did a lot of PPE production over COVID with a PLA with silk in it because it didn't shatter when it broke. It would like flex and bend almost like a PET. And so if I'm attaching something to a human, I want to think a lot about what its fail state is like. So I would say it depends on a lot on the material you're choosing and running tests on that material. What do you think, Rick?
Oh, yeah. We tend to, for situations where we need the strength, we tend to rely on nylon. However, having said that, nylon has some odd properties.
It could be a nightmare to print.
Well, it can be, but the worst part about it is if you need to thermoform, it does something to the nylon and makes it extremely brittle. We don't know why. It's just characteristically why it does that. But if it doesn't require thermoforming, we found nylon to be super strong and probably one of the strongest materials we use. It's really not particularly expensive either. It's pretty much on par with ABS. So for us, it's TPU, ABS, nylon is kind of, I guess, our three biggest.
Go ahead, Dave.
Yeah, so again, I'm showing up for the first time, but I'll throw my 2 cents on the table if it's okay. Is this more of an open forum? We can just talk?
Absolutely.
Okay. Yeah, so I support folks in the farming region of Southeast India. So, there the infrastructure's poor, and just recently, for example, a kid left church, little Christian church, and then the child picks up a wire to get it out of the way while they're playing. It happens to be a 220 line and they lose their hand, right? There are all these different incidents. So I jump in there, try to help, see what I can do. And then as I'm working through this and the lack of logistics, the lack of technology, I mean, there's just absence of just about everything you can imagine in some of these regions. I was thinking, like, what can we do to streamline this whole effort? Because it's a tremendous swell, like a groundswell of individuals like us that are interested in helping. We have resources, materials are available, we're improving. So I was thinking, has anyone ever considered having, like regional distribution centers and actually having, like, when you go to the shoe store, their shoe sizes, right? They basically have this little silly thing that's been around since the 40s that you put your foot in and you get some basic parameters of the feature called a foot, right? And then you go and try some different shoes on. And I can guarantee you that just if you took scans of your feet with high technology and got a beautiful scan in free space, now you actually start moving that foot, putting pressure in different areas of the foot, and you're going to say, hey, this doesn't fit, right? And the feet are a little bit different than hands. I get it, because hands are in fact more in free space. But so my thought was, why not come up with sizing, a nice distribution center for all the makers just to send shoes or prosthetics of these particular sizes in when inventories go low. And then the focus is really on compatible interface material. So someone was talking about silicone, but not to shim things up, if you will, right? If your things doesn't fit, like a door doesn't fit, you put shims in there and all these things because there wasn't good design work or manufacturing was poor, whatever. But actually get good at the compatibility work, because there's not going to be any two hands that are exactly the same, for example. So the effort is really in the integration, the interfaces, comfort. And then also, I did make a few of these 3D printed hands. I love it. Okay, I'm nothing negative here, but from my perspective, there's a certain lack of robustness in the design. the rubber bands come off, the plastic breaks pretty easily, even if you choose the higher strength plastics. I mean, a lot of kids are using these, so the kids are rough and tough, right? This stuff is just not going to last. So that's a lot of stuff. These are my 2 cents, and I'll just share my thoughts. Thank you.
I know Rick is thinking about a lot of stuff about durability with materials in the same direction.
Yeah, the fingers we're printing right now, Dave, are all metal, or that we're using now. And the specific design we're working with right now doesn't even require rubber bands or anything of that nature. And these things are strong. They're
have you thought about conductivity of the metal and safety?
well, you have to be concerned about that, but that's why we never allow anything electronic or any of those components to touch the individual, and that includes the Mayos. I don't use Mayos for that reason. I don't want to plug people in, you know,
Right.
to the electronics, especially children. I do not hang LiPo batteries on children. I just won't do it. But these fingers that we're working on now are so incredibly strong that it's even surprised us.
Awesome.
I've got one in the other room. Let's see. I don't want to hold you guys up.
Rick, what's the name of the design that you're using for this?
Well, we never really print the same thing twice. We tend to like to take, from a design perspective, we may use a Koanu arm with an ARX hand. We mix them all up. We don't ever, I don't think, print everything together like that. We just don't do it. What you just said about everybody being different, you're exactly right. And we've just never found anything that's a one size fits all. And we like to keep it modular. So if something breaks, we replace the module and we move on.
Yeah. So the closest business model that I could think of was shoes, right? So basically, we're trying to get everybody fitted with a pair of shoes that no 2 feet are alike. They go through rough and tumble. Got a lot of different materials, sizes, and styles, and so when you kind of like that's what I do in my mind. And most of the people around the globe, even the poor folks, have shoes, right? And because there's this distribution center, so if you can think about these prosthetics like going out like a pair of shoes, and then there'd be a shoe person that actually helps to get the right fitment, and they're the ones that make sure that 7.5 works better than 8, and you know how that is, right? When they were just trying to compromise through the best fit. But all the makers, that's not our forte. So all the makers basically send all of our pre-designed materials into a center, and then that gets shipped out. So it's actually more of a formal business model process. That's just
I have personally never used that. We design every one of them for the individual.
Right. That just like the cobblers did back in the 1700s. That's what they did actually back in the day when that was starting.
What I was gonna, if you don't mind, and I don't want to hold up your meeting again. I'm trying to get my kickstand to work here so I can show you guys something, because I can't hold the phone up and do this. But for instance, Dave, this is kind of directed at you. This finger, okay. Imagine, oops, now I've done it. Imagine that you have a small, you're trying to build in a country that doesn't even have 3D printers. Well, pretty much everybody has bicycles. Look at this. This finger is made from bicycle chain.
I like it.
And this thing will grab on to almost anything and has a tensile of 2,200 pounds.
Yep, I like it.
Right. And we put them on hands. Now they look a little scary, but this hand in particular, the ARX, is the one we're building right now, and we're putting the new fingers on it. What our design criteria is to put these fingers on all of the e-NABLE hands we're using.
Okay.
Because you don't need the infrastructure to do it. A third world country has bicycles, so they can basically make this out of a bicycle chain.
I like it. Nice
It's
work.
got built-in roller bearings. See, roller bearings are built in. Everything's built in. So consequently, the springs, now we've also now just figured out how to get rid of the springs. We don't need the springs anymore. So this is an older version. The new one, we've eliminated the springs completely in the finger itself. And I'm going to get ready to show you guys that as soon as we get the build complete. We're waiting on some parts from Amazon. So the new finger is going to be even crazier. But this thing is, these are so strong and it's scary looking, but they're strong, they're light, and anyone can build it. All you need is a soldering gun.
Very cool.
And then I guess the complexity becomes the fit of the middle part, right? How do we actually get that all integrated around a socket that will fit someone's physiology?
And that's what's interesting. When you keep it this simple, like a bicycle chain, it bolts right onto the hand. So you just put a bolt, you run a bolt through it, and it's on the hand now. So you replace as many fingers as you want. One of the things we'll typically do is to say if you have a limb difference that say they have 2 fingers, and you see that a lot. You just take your CAD model and you pierce off it's real simple to do with an XO, and you just pierce off the fingers you don't want, mount the new ones on, and off you go. Now the parametric design, as Ian was alluding to, that's really the really cool way that you get these to fit properly. There's a whole group of people that have an amazing amount of talent with the measuring and the sizing. If that's something, you know, that you're concerned about, they're very good about helping to teach you. They've got some really easy to use spreadsheets, things of that nature that will help you with sizing. I tend to really like the parametric designs the best because it also eliminates a lot of the parts. So instead of having to, every time you make a hand, say an inch wider, you don't have to go out and buy all new screws. You know, all the screws, everything fit the holes now because the holes stay the same size, even though you changed the size of the actual hand or the arm. So the parametric designs keep your inventory lower.
That's a really good point. There's so much complexity. And some of these designs that Rick is talking about, I haven't actually tried myself. The Quanu and the ARX are really like the future facing designs. But I think most of the education chapters that I know are focusing on, I think I put a link in here to the Sage Prosthetics group. Those are sort of the most popular platforms. The Phoenix, the Raptor, the Kinetic, and then slowly getting into these more advanced
But it's super fast, super easy. You know, one of the downsides are using rubber bands. Let's face it, they don't last. You know, so you're constantly changing the rubber bands out. I mean, they work, but you know, you have to remember that you have to train your recipient on how to fix it themselves, because those rubber bands only last, you know, a few uses. They're not particularly robust. We don't use them. I don't like putting rubber on anything except TPU that it's actually going to hold up, because anything that's being stretched repeatedly, it's going to break down very, very quickly. We learned our lesson from one child we have has no arms. So what's he supposed to do? He can't put new rubber bands on it, of course, by himself. So, you know, we try to make it a little more robust than that. But it's a great place to start. People love them. You can put them together fast, easy, and you know, you kind of work your way up. It's like any other, you know, any other type of design. You got to start somewhere, and you're just going to get discouraged if you just go right straight to the, you know, Quahu. It's going to hurt. That thing's even hard to thread after it's been printed. You know, just assembling it can be difficult. It's a wonderful design. It's very rare we use any one part. Like we use a Quahu version 3 for the top part of the arm. We use Quahu version 2 to build the bottom part, and then the hands, we very rarely use the Wahoo because of the way the fingers are attached. That's its weakness, is the finger attachments.
And this is sort of the whole design challenge, is there's so much complexity making something that'll adapt to a human and then survive use in the real world.
Right. Oh, you're exactly right. And if it hurts, it doesn't fit, or it breaks a lot, they're not going to use it.
You know,
It's not going to happen.
Nush, this is an interesting thing for your research to note too. Maybe there's different platforms that we start with for like design literacy to learn how to build prostheses as a maker. And those might be different from the optimal designs for recipients who actually need a daily use object. And I like what Rick was saying, a spectrum of design where like maybe there's an entry point that's somewhat useful, but then we get to something very practical later after we've learned the platform.
Yeah, because there's room for all of them. I mean, however simplistic. We had an earlier meeting today where we were discussing the prayer hand, which most people haven't even seen yet. And the prayer hand's actually pretty neat. We're going to be printing one here very soon, but we're going to be outfitting it with these fingers, which will be killer, because if we can get the prayer hand pared down enough, we can use some of that technology for people that are doing builds that aren't particularly good with CAD to allow them to do partials.
Yeah. So Rick, if those people in prayer are all holding hands, I guess you could call it a prayer chain, right?
You could. And I think what's really nice about it is it's super, super simplistic. It has a lot of channels in it to run your tendons. And I think the original design criteria, I don't hold my feet to the fire on this, but I think it's originally was designed as an exoskeleton for people that had neurological damage. But, every one of these designs, to me, it makes the most sense to try to get these designs to where, they can modularly snap together with other designs. And that's one of the reasons I like the NIOP project, because the NIOPs, offer different interfaces to connect this hand to that arm, or this wrist to that hand, where it wasn't really designed that way, but they build the components that allow you to snap these things together. We build our own, as needed, but to me, it makes a lot of sense to do that. It opens up your variables, that you can use to provide someone with a really nice build.
Yeah. So my perspective, like I say, as a newcomer, I worked at Ford Motor Company in vehicle production for all my life. So for me, the manufacturing processes, the mass production system, right, this huge thing. So in my mind, I've got all these people out there that want to drive a car. They don't have access. So you need to have this system that just gets the material fabricated in a consistent way. There's specifications all along the way. So when the vehicle, or in our case, this product exits and goes to the customer, they're happy. So in my mind, that's just what's missing in the e-NABLE process. When I go to the website, it's all like very specific artwork, but in actuality, the Henry Ford vision was, rather than having one-off cars that were each hand built, come up with a system so that you can make mass production of these cars that are inexpensive, right? He wanted very inexpensive, so every family could afford them, and then have them proliferated through this system. So in my mind, I still have this, and I'm probably being rude and almost today, but this is talking too much, but this is my view on this is, wow, they have all these people. It's like this big factory. It's just chugging, ready to go, a lot of energy behind it. And all we need to do is get the system set up, and we can kind of like change the world, because I think there's a lot of people with good souls. They want to get into this and get these engines running, having people, the technical folks like Rick and others, kind of clear the path so people can, light up their engines, so to speak.
Totally.
Well, one of the things you mentioned that makes sense is when you said shoes. you take a child, for instance, we tend to cut off at about 3 years old. That child's going to need a minimum of 25 of these by the time he's of age.
That's a great
Right.
customer base, actually, right? You think
Yeah.
about it, right? You've got
And,
customers
and they
lining
don't
up.
have other options. Okay, you could go, they can't just go to the local, ortho and, get anything for under 30 grand. And the average parent just can't do that.
Yep.
So imagine you got a child, and you got to replace his $30,000 to $150,000 shoes. Okay,
Yeah.
a couple times a year. Well, that wouldn't be in the average budget. So having said that, buying a car is all well and good, but most people, their butts are relatively simple, so it's going to fit in the seat. I mean, you have to make it to where you can accommodate a majority of the people, whereas shoes are still your best example, because you just can't go hand somebody a pair of shoes without fitting them and blah blah. I think that's where the chapters come in a lot, because the chapters tend to deal with the individual, and then they reach out for help. So I'm not sure you've seen the entire process yet. Chapters may actually be doing the sizing.
This is a great point, and I think there's a future there with the customization, the vacuum forming, more rapid, even more rapid prototyping.
Yeah.
I also want to be respectful of everyone's time. We are at the hour, and I have to depart. But if others would like to stay, I think this is a lively conversation, and I love these questions.
I'll leave it up to you guys. If you'd like to chat, I'll stay.
I
If you guys got to be somewhere, that's okay too.
I have to leave as well, but I'm happy to turn hosting over to you.
Excellent. Well, great to
Yeah.
see everyone, and we'll be back in a month. And I hope that we can build hands together and innovate this platform until we can get that mass production and
We
more
gotta get
rapid
together,
customization. We got to meet
You
in
and I, Ian,
face to face.
We got to get together. Yeah.
Awesome. Well, everyone, have a great week, and we'll see you next month.
Cheerio.
I'll leave it to you guys if you have additional
Well,
questions.
Rick, I have a question for you. For the vacuum forming, what do you use for mold?
You mean as a positive? So you have
Yeah.
the positive, and then you create.
Yeah,
Like I said, we might take let's just make it super simple. A phone that has light